Today we are going to discuss another theorem in the first unit. So that is so if L of f of t is equal to f bar of s, then Laplace of f of t by t is equal to Laplace of f of t by t. That is means division means integration. Integral is to infinity f bar of s into ds. F bar of s into ds. So this one you have to remember. Integral s to infinity f bar of s ds. Laplace of f of t by t is equal to Laplace of f of t by t is equal to integral s to infinity f bar of s ds. Okay. So first we will consider the f bar of s. F bar of s is equal to nothing but by the standard definition. Laplace of f of t definition, integral 0 to infinity e power minus st into f of t dt. So division with t means always you have to remember the integration. Therefore integrating both sides, integrating both sides. So what happens is, so integral s to infinity f bar of s into ds is equal to, so integral s to infinity integral 0 to infinity e power minus st into f of t into dt and ds. Okay. So this integral s to infinity f bar of s ds is equal to, now we change the order of integration. So integral 0 to infinity integral s to infinity. So integral s to infinity relevant terms related here e power minus st into ds. This remaining terms f of t into dt related here. Okay. So that is nothing but integral 0 to infinity f of t into dt into this integral s to infinity e power minus st. This if you do the integration e power minus st by with respect to ds, means you will get minus t into minus t. Okay. So the between the limits s to infinity. So that is nothing but equal to integral 0 to infinity f of t into dt into, if you substitute minus infinity upper limit, so you are going to get 0 minus, so if you substitute yes, so in place of s, if you substitute s, you are going to get e power minus st by minus t. Okay. So that is nothing but equal to integral 0 to infinity e power minus st into f of t by t into dt. So this is nothing but equal to the, by Laplace definition, Laplace of f of t by t. So integral s to infinity f bar of s into ds is equal to Laplace of f of t by t. Therefore hence proved. So first what we did is, so this is the statement. This is the statement of the theorem. So if L of f of t is equal to f bar of s, if L of f of t is equal to f bar of s, then Laplace of f of t by t is equal to integral s to infinity f bar of s into ds. Okay. First f bar of s by the definition of the Laplace, this is the formula, integrating both sides because it is the division. So both sides integration between the s to infinity, you are going to get like this. So ds and relevant terms f of t dt, the remaining terms I am writing inside the 0 to infinity integral. So integral 0 to infinity f of t into dt, this integration of e power minus st is nothing but e power minus st by minus t between the limits s to infinity. So if you did that one, you are going to get 0 minus e power minus st by minus t. Okay. Therefore integral 0 to infinity e power minus st into f of t by t, because minus minus get converted into plus, f of t by t into dt. Okay, therefore this is nothing but according to the Laplace definition, Laplace of f of t by t. Therefore hence proved. Okay, thank you.